Okay, so in the Lex assignment, as I told, we will be implementing the lexical analyzer for generating tokens of Java program. Let us in brief firstly see about what exactly is Lex. Uh, like I told, it is a tool which we use to create or build or generate our own lexical analyzer, right? Required for our own purpose, right? So definitely, uh, we will use the Lex tool for creating our own lexical analyzer. And as I told, lexical analysis is the very first phase of any compiler, which takes input some source code, maybe from any language, maybe a binary code as well, depends upon what we are using the lexical analyzer for. So it will take some source code as input and it will generate tokens as output. Right? This diagram is very important. Try to understand this. As I told, we will be using source code as an input, so you can assume that this if statement is a part of some input code, and while we perform lexical analysis, after that we have this token stream. So every identifier, every symbol, every keyword from the given source code will get separated and we'll have a token stream, right? So this token stream is given to the next phase of the compiler, that is the syntax analysis later on. Okay, fine. Uh, yeah, so if we are trying to develop our own lexical analysis, so we'll have to do it with the help of the Lex tool, and the Lex tool only understands Lex language. Okay, how the Lex language is, how to write it, we will see in a while. But just remember that we will have to use the Lex language, which is no different from simple C. But how to arrange that, we'll see in a while. Okay. And then finally, with the Lex tool, when we feed this Lex language to the Lex tool, it will transform, it will generate some transition diagram. It will, depending upon the rules that we have defined, it will create the transition diagram, and it will finally generate a code, output code from the Lex tool, and it is stored in this file called as lex.yy.c. Okay, so the flow goes something like this. Okay, observe this. So whatever Lex language code we are going to write to create our own lexical analyzer, so that is created in a file with an extension .l. Okay, and this .l file is run through the Lex compiler to get the resultant file. As I told, lex.yy.c. Okay, we'll get a C file. Now this, always whatever Lex language code we write, if we run it through the Lex tool, we'll get this file as a result. Okay. Now we have to run this .c file using our normal C compiler, right? GCC. And as usual, we will get some output file, a.output file by default. Okay. Now this a.out file is nothing but our required lexical analyzer. Understood? Now when we run this output file, uh, a.out file, then in that file we will definitely be reading some Java program file, input file, and then it will result in some sequence of tokens. Okay, so understand this flow. If not clear, I'll explain again. Is it fine? So basically, we have to create only one file. Which file? That is the lex.l file, right? And we need to have one more file, that is our Java source code. Okay, of which tokenization is to be performed. Okay, so that is the input file, and this is our source program, the one which we have to create, .l file. Fine. Okay. Understand this structure of Lex program. It is very simple. So there are three sections of every Lex program: declaration, transition rules, and the auxiliary functions. Okay, auxiliary functions usually have one common function, that is our main function, from which we are going to call the uh, Lex code, I mean, right? But apart from that, if there is any other function which is used in the transition or in the action part of the transition rule, then we will have to define those functions here in the auxiliary part. Okay, we'll see this in detail when we see an example. But for now, understand the format of writing all this. Okay, so you'll start your declaration with a percentage, an opening brace, and then again a percentage and a closing brace. Okay, in that you will declare all the variables, all the arrays if you want a structure, even if you want to declare a function, all of those declarations will come in this part. Okay, then you will write a double percentage sign to separate out the declaration section from the translation rules, and all the translation rules must be written in this curly brace pair. Okay, what is the format of translation rule, we'll see in a while. And then finally auxiliary functions will be separated from the translation rules with the help of another uh, uh, double percentage sign. Fine. Okay. Yeah. So declaration section, as I told, will include declarations of variables, functions, structures, whatnot, whatever is required for your program. All of that will be declared in this part. Okay. So when we develop the .l file, this is the format for developing the .l file. Okay. Fine. Translation rules. So every translation rule, for example, if I encounter, let go back to the previous diagram that we saw. Yeah, this one. For example, our lexical analyzer encounters this if, right? So what uh, what action is to be taken if we encounter this if? That is called as the rule. Okay, that defines the translation rule. Okay, so if you find this pattern in short, so definitely lexical analysis means what? You will have write a regular expression, right? That means so. And if we identify, if the lexical analyzer identifies certain pattern, then what action is to be taken? That we have to define as the translation rule. Okay, so there is a pattern. We have to write the pattern, and the action to be taken once the pattern is identified, that action is to be written inside the pair of curly braces. Okay, we'll see an example in a while. Things will be more clear. Okay. Now, whatever action you have to take, it may be a simple, since we are only expected to separate all the tokens, so we will simply print whatever is encountered. Okay, we'll see how to do that. Auxiliary functions, as I told, will hold all the functions that are used in actions. Okay, so apart from the main that is mandatory, we need to have some set of functions to be defined in the auxiliary function section, which are used as action. So for example, if I encounter, um, if I encounter a specific keyword, I need to call a function in order to handle that keyword. That is, handling means it is called as an action. Okay. So as a part of handling any keyword, if at all I have to call a function, then that function's body will be defined in the auxiliary function. Okay, as simple as that. Okay, fine. So these are some links. We'll come back to these links. We'll firstly see a sample code. Just a moment. Okay. I hope the Java code is visible. Okay. So this is the sample Java code that we'll be using that we will be using as a input file for the lexical analyzer. Okay. So what it is, we have simply imported whichever packages we want. We have defined a public class called as token. We have two data members of the class, roll number and marks. And in the constructor, we have provided we have initialized those two data members, and we have a main method over here. Okay. As usual, we will be creating an object of the class itself, and then we'll print roll number. There's no we don't have to observe the output of this Java. This Java program only will be used as input to the lexical analyzer that we are going to develop in by using the Lex tool. Okay, so this is a simple Java program written for that purpose. Now let us come to our main program, that is .tel file. Okay, so if you can see here, just a moment. Yeah, here I have created a token.l file, if you can see, right? So this is a file type of this is L file, right? So what we are doing here is I have as I told, first we will have the declaration section, right? I'll just zoom it up. Yeah. Is the file readable?
Yes, sir.
So first observe this part, this portion, which is highlighted. Okay. This is the declaration section. So I required a few header files. So I included that in normal C. We have to include. Then I required a few variables down here, which I have declared. Okay. I required a method just for the sake of demonstration. I have used this method insert. There's no such logical use of this method of this function, but how to use a function for that demonstration, I have declared a insert function over it. Okay, and I have a also. Okay. So what we are going to do after this is the main part of any .l file is this translation rules. Okay. So here below we have a double percentage sign, and then we have the translation rules. Okay. I'll zoom it up a bit so that you can understand it well. So since my lexical analyzer is only responsible to perform uh, tokenization of Java program. Okay, that is the motive of my lexical analyzer, right? Tokenize the Java program. Okay, so I'll start with the very first line of my Java program, or what is expected in my Java program, and then I will define rules, what to do if I encounter a given pattern. So there are two ways to define any pattern. Firstly, if I encounter such a pattern, which pattern? That first I have import. So I have put this import keyword in double quotes, plus I have a space in between, right? And then I have Java dot. This is a pattern, Java dot. And then after that dot, I may have any combination of small or capital letters. Okay, any combination, and that is why this star is present. Clearly, last time you have seen this must have been given regular expression, right? Any combination of that is what package. So package name can be any alphabet, right? Either capital or small. So any capital, any small letter from A to and any capital letter from A to Z, capital A to capital Z. Okay. Yes, should be a dot, and followed by the dot there should be a star sign, again for inclusion of, for importing all the classes present in that pack. Understood? So all of this, whatever I have defined over here as pattern, if such a pattern is found, then what to do? What to do in that case? So that is called as action. We know action is specified in a pair of braces, right? So here we have a pair of braces, and if we encounter, then this pattern or this text is stored in a variable called as YY text. By default, whatever we encounter, whatever the lexical analyzer encounters, that token gets stored in the variable YY text. Okay, what we are doing as action, we are simply printing the text. Pattern we are printing. Understood? We have a statement in which we have displayed entire import statement from Java file, and we have identified them as processor directives or statements, whatever you want to categorize them as. Okay, so the same thing, and followed by that we are putting a another printf printing out the next line identifier. Okay, simply because whatever next token, right, that will also get printed on the next line. Okay, so this is the action that we are taking if we encounter such a this pattern. Clear? Any doubt in this? Anyone? Any doubt by far? Anyone? Okay. Similarly, what is to be done if I encounter a void? So these are all the keywords, right? Void, main, public, system, out, println, class, static, whatnot. Okay, you can add any number of keywords you want. Okay, so these are all, this is the entire pattern. Okay, and all of those keywords are separated with the or. Okay, you know this. So if it is a void or it is public or it is a system, whatever it is. So if such a pattern is found, then how to handle this? What action to take? Simply the encounter token as categorized as keyword. Clear?
Excuse
Similarly,
me, sir.
if I find, yeah,
Sorry to interrupt. Actually, there was some connection error on my part. So can you please explain the second line again?
yeah, yeah. So like we identified the first pattern over here. If I find a pattern as VORD, okay, pattern MAIN, or there is a pattern PUBLIC. So how to handle this? What action to take? That is written as a part of the action part for this pattern. Okay, and how we are handling? We're just printing the pattern what is encountered by the lexical analyzer, and we are categorizing it as keyword. So a line, and ahead of that, that pattern will be printed. The same thing what we did earlier for the preprocessor directive or the import statement. Understood? Now,
Yes, sir.
after, yeah, okay. So after that, if we encounter a int or a string or a char, so if such patterns are encountered, those are called as data types. Okay, so we are going to print data types, and we are going to print that pattern itself. Okay, so this is the action we are going to take if such a pattern is encountered. Fine. So as I told, there are two ways of representing patterns. One is you can directly put it into double quotes, that I am damn sure. This is the way it will appear. This is the pattern it will show. IMPORT. There's no S to this. There's nothing after T or before I. So if that is specific, I am able to put that pattern inside double quotes as it is. But uh, if I have to select from a given set of choices, then what I do, I provide that pattern in square brackets. Okay, you can observe here and zoom it up a bit. You can observe here in this line, I have used a pair of square brackets to define pattern in the second method. What is the second method? Use square brackets and place all the symbols inside the square brackets. Okay, which are those symbols? Now, normal closing bracket, opening bracket, closing brace, opening brace. If these symbols are encountered, then what do I have to do? I will simply deal with that pattern as printing that pattern, identifying them as brackets. Understood? So either of these brackets are encountered, I will print them as brackets. Got this? This YY text will capture that pattern, and that the same pattern we are going to print it. Okay. Again, if we encounter arithmetic operators or such symbols, then we will categorize them as arithmetic operators and then we'll print them up. Okay. So the set of these separated symbols. Okay. If there is such a set that we have to define as a pattern, then we use the square brackets. Similarly, if we have to identify delimiters, then what are the delimiters that we use generally in Java? We have dot, we have comma, and finally we have a semicolon. Right? These are the delimiters generally used in Java. So I'll categorize them as delimiters. Okay. Then there is number. Now any range of number from 0 to 9, right? If such a pattern appears, then I'll categorize them as number. Understood? But you can observe here, in order to identify that pattern as a number, this should be a positive closure. You know, it should not be an empty string. Understood? Remember this, whatever we do in lexical analysis that has it has direct relation with regular expressions. So what we studied in regular expressions, if there is a positive closure, that means there can't be any empty string. There can't be a epsilon, if you remember, right? So in order to categorize this as a number, it has to have either of this uh, either of the legitimate symbols starting from 0 to 9 within this. Okay. So that is how it goes. Fine. And finally, the last pattern that we are going to define is for the variables. Okay. So for a variable to be identified, this is the normal pattern. Okay. Let us focus on the first pair of rectangle brackets. This part. So what it shows, what is the rule of having variables in Java? It should start with a underscore or any letter. I mean alphabet. Okay. So that is what we have done. Either it should be a underscore or it should be a character uh, in the range of A to Z or capital A to Z. Okay. But it may or may not be followed by uh, another alphabet or a numeric value. Like if I want to have a variable A1, so it is possible, right? It may or may not be present. That one may not be present, or it can be present. So that is why again uh, we have put a star over here so that uh, epsilon is allowed, empty string is allowed for this pattern. Clear? And if we find such a pattern, we print that variable's fine. Along with that, as a part of action, close the activity yet. If we encounter variable, we'll simply print that variable. Along with that, our action includes call function. Okay, our also includes calling of a function called as ins. Okay, just this is just for the demonstration. It is not at all compulsory, but if at all we have to call a function in the action part, then how to do it? So you'll simply call the function, pass the parameter. Here I have passed that as the string, the variable name that I have captured. Okay, so I'm passing this uh, captured pattern as a parameter to the insert, and then print a slash. But this is how station section works. Any doubt in this? Anyone? You can have as many rules. I have identified a few, but you can have uh, a rule for exception handlers. Like if you encounter try, catch, finally, what you have to do in that case. So you can have a rule for that. You can have a rule for comments. You can have a rule for many other operators like increment, decrement is not included here. So you can have a separate rule for that and take action upon it accordingly. The prime task that we have to do here is tokenization that we are able to do. How do we define the token? With the help of this pattern. If we identify such a pattern, that is declared as one token. And if we encounter that token, what action is to be taken? That we have to show over here in the action part. Yeah. Let us see the auxiliary function part, the third section. Okay. So as I told, uh, to start the auxiliary function section, again, percentage sign is to be kept, and then we'll come back to the insert method is compulsory. Okay. In the main method, this particular line is important. Lex method function calling the important part in the main method. What it will do, it will start execution of the above code, this code. Okay, when we call Lex. Okay, but prior to that, what we have to do is we have to read the .java file, which is our input file. So we are having a file pointer. Usually we use the fopen function in C to open up any file. So the file name is .java, token.java, and we are opening it for reading purpose. Fine. Now, whatever file pointer we are using, that file pointer has to be linked with input string. Okay, this is nothing but an input stream, right? So it has to be linked with the input stream. Okay, same thing we are doing. If you accept, if you create a, if you open a file for reading and directly store it in in, that is also good. But for your understanding, I've kept this step. Then now, yeah. So what we are doing, whatever variables we have encountered, those variables we are storing in this structure or in the array of the structure. That is what we are going to do. Okay. So basically, if I am having, let me go back to the Java program. Okay. Yeah. Over here. So how many variables do I have? Two variables, role and marks, right? So whenever these two variable names or such a pattern will be identified, what we are going to do? If you remember here, what we did, we printed it as it is, and then we called the insert function, right, with that pattern as parameter. So what the insert method is going to do, it is simply going to check it. We are going to add that pattern into into this structure, into the structure variable, right? Sim of I dot name is going to be that variable. Okay, so that is what we are doing over here. We are simply copying the X, that means our pattern, into the structure variable name for that particular count. Count is kept as 0 initially. Okay, and then we are incrementing the count in order to accommodate the next thing. Okay, so when this will be done, if that variable is already present in the list of structure variables, then it will not be added. And the same logic is present over here. We are firstly comparing with all the entries of the structure variables that we have in the name field of all the structure variables is compared with X. If it is equal to 0, then we keep the flag as 1 and break out. That means uh, the pattern is there already in one of the structure variables. But if it is not there, then we are copying it. That is the thing that we are doing with the help of insert. Now, why this is important? As I told, I I'm just demonstrating how to call a function from the action part. And since the function is called, we have to define that function in the auxiliary function part. So this is what the sample definition of insert function is. There's no uh, logical reason why we have kept this insert method. This is just for demonstration purpose. But definitely you will have to use the main method and call the yylex method from the main method. Okay. Now, since we have accommodated the or we printing the contents, we are defining a tabular format, and then we are passing the name field of every structure variable. That is what we are doing. We have end our main method and what is mandatorily required after the main method, after the main function, is the function. Always you have to define this wrap function. Yeah, for Windows, so you just need to just type. You can find the same it in the video as well. But you for Windows, you will type Flex 2.5.4, and after that, whatever first link you find of source fork, you have a here below you have a exe, right? So just click on that. It will ask you to save, uh, and it will download a setup for you, which we have already downloaded. So here is how this Flex will get downloaded. Okay, and again after that, to install Yak after Flex, you will type bison. Okay, so bison 2.4, I think. Yeah, bison 2.4, and again you will be using the first link of source fork, and here you have bison 2.4.1 setup. Okay, you have to install this. Don't directly click on the download latest version button. It will only download a separate setup which we don't require right now, right? So while installing bison, you have to click on this. Okay, again both of those setup will get downloaded, Flex and bison. Here you can see these two. You install them separately, double click, on Flex first, Flex setup, click on next, install. Similarly for Bison. Now, once you do that, uh, what we have to do, once you do that, make sure that you install it in C drive, not in C drive and program files. Okay, there's an issue with that. So when you install and when that path comes, so by default it will have program files. So just erase the program files part so that this GNU Win32 folder gets created in the C drive itself. Okay, and then in the bin, you have to copy this path till bin, and you have to set the environment variables, the path system variable path. Okay, as we do it for JDK generally, right? Now, once that is done, you are done. You are ready to execute your .l file. But since we are using C, so it is expected that you have a C compiler. Okay, so you need to have GC already installed, right? That is a prerequisite. Now, all these files are output files. The only two files which we have is the Java input file and the .l file. So this is our .l file. So just go to CMD on Windows. You can on Ubuntu you can use terminal obviously. So we'll go to desktop, which has my source file, and then I'll type flex. Name of my file is .l file is token.l, right? See, once I compile the .l file, I will have this lex.yy.c file. Okay, I'll get this file. Okay, now once I have this file, uh, I will have to use GCC uh, x dot uh, so I'm compiling this C program, and as usual in Windows I will run the a.exe file, and these are the tokens that I have got. Okay, fine. So first up, let me go. Yeah. So first line of my Java code is the import statements, that is preprocessor directives. So it has printed them as it is since the pattern was matching. Then I've got keyword as public, keyword as class, variable as token. So now there's a challenge how to separate out the token from the class name. So what you can do over here, it is not a variable, right? It is a class name. So how you can define a pattern? Simple. Whatever pattern you wrote for variables, the same pattern you will write, but just before that, what you will mention is something like this, right? Here, double quotes, there should be a class, keyword, space. I mean, uh, there should be a plus, then there should be a space, plus, and then whatever pattern you have for the variables, right? Right. This is the pattern for identifying the class name. Okay. And as action, you can print class name and whatever the YY text is, right? So these are the small things that you have to do to, you know, define your lexical analyzer. Okay. I hope the idea is clear to all.